Welcome back to the Deep Dive. Today we're tackling something pretty specific, high-capacity AV distribution.
Yeah, we're moving past those traditional big iron matrix switchers.
Exactly. We're digging into systems that use networking, standard IP networks, to handle just a massive number of screens.
And our focus today is based on the product specs for these WolfPack 4K 30Hz HDMI over IP matrix switchers.
Right. The source material says they can handle up to 70 TVs. 70.
Which is, serious scale for AV. We're looking at the blueprint, essentially, understanding how they make this shift from fixed hardware to, well, IP.
And the core goal is pretty straightforward, right?
Mm-hmm.
Getting 4K video, specifically 4K at 30 Hz, out to potentially dozens and dozens of displays.
That's it. Quality video, lots of endpoints.
The scale itself is kind of the first thing that jumps out. They give this example, a 14 by 32 configuration.
Mm-hmm. 14 by 32. So 14 inputs, 32 outputs.
That's 14 sources, like satellite boxes or media players feeding 32 different TVs, all managed from one place. It really is a different way of thinking about moving video.
It absolutely is. And that 14 by 32 setup, it means you need 14 transmitters, the TX units,
right,
and 32 receivers, the RX units, and crucially, you need a pretty hefty network switch to connect them all. The example uses a 48-port PoE switch.
PoE, power over Ethernet. So the network cable powers the units too.
Usually, yes. It simplifies the wiring quite a bit. This isn't your home router. It's dedicated infrastructure for AV.
Okay, so let's unpack that foundation. The core tech is 4K 30 Hz AV over IP with PoE.
Right.
Now running 4K video, even 30 Hz, over a standard 1 gig network switch. That sounds like a lot of data. How do they manage that without just, clogging the network?
That's the million-dollar question, isn't it? The answer is in the compression protocol they use.
Okay.
The specs explicitly mention H.265.
H.265, right, the high-efficiency codec.
Exactly. It's very efficient at compressing video while maintaining decent quality. It lets them squeeze that 4K 30 signal, which would normally need much more bandwidth, down so it can run reliably over standard 1 gig infrastructure.
So you don't need to rip everything out and install super expensive 10 gig networking just for the video.
For this system, according to the specs, no. You're relying on the H.265 compression that's built into the transmitter and receiver units themselves.
Gotcha. That makes sense for deployment cost and the physical cabling.
Standard stuff, really. SAT-T6 cabling.
Right.
Which the literature says can run the signal up to 450 feet. Pretty good distance for large venues.
Yeah, that covers a lot of ground.
And it supports cascading Ethernet switches. So you can link switches together to reach that 70 TV number, or potentially even more if your network design allows it.
Okay, let's talk about a specific hardware detail that seemed really interesting, this dual role unit idea.
Oh yeah, that's a key point for operational efficiency, definitely.
It sounds like the transmitter, the TX box, and the receiver, the RX box. They're actually the same physical piece of hardware.
That's what the source material states. One single extender unit. And you basically tell it what job to do, input or output, using software during the setup.
Wow. Okay, so think about the logistics. A tech goes out to a job.
Right.
And they need, say, one more input, but they only have receivers in the truck. Here, it doesn't matter. They just grab the same box.
Exactly. Same box, listed at around $250 according to the source. They plug it in, configure it as a transmitter, and they're good to go.
That simplifies inventory massively. One SQ instead of two.
Huge win for integrators or organizations managing lots of these endpoints across different sites. Streamlines everything, buying, stocking, spares.
Makes total sense. Now, quickly, compliance. HDCP is standard for protecting content. But they also mentioned SEC security compliance. What's that about in an AV context? Is that like financial market security?
It can be related, yeah. In professional AV, especially systems networked over IP, SEC compliance often means the system meets stricter standards for network security, data handling, maybe network segmentation.
So preventing the AV system from becoming a backdoor into more sensitive parts of a corporate network.
Pretty much. It's about ensuring the network stack on the AV device itself is robust and secure, especially important in corporate, government, or financial environments where network security is paramount. It adds that layer of trust.
Okay, good clarification. So we have H.265, standard C6, this really flexible dual-role hardware. Let's get into the scalability aspect because the literature uses the word unlimited quite a bit.
Yeah, they do. Unlimited field upgradable, unlimited sources, unlimited HDMI ins and outs.
Which in the real world usually means unlimited until you run out of network capacity or IP addresses, right?
Pretty much, yes. It's not infinite, obviously. It means the system's size isn't limited by the number of ports on a single physical box like a traditional matrix. The limit becomes your network design and budget.
So if you wanted to go beyond that 70-screen example, what's the likely first bottleneck? Network switch capacity, power over Ethernet budget, just managing it all.
Probably core network bandwidth and switch capacity, especially if you're cascading multiple 1 gig switches. Even with H.265, 74K streams add up. You need a solid network backbone.
But the promise is that flexibility.
Mm-hmm.
Any in to any out, any way you want. Any source can go to any screen anywhere on the network.
That's the core value proposition of AV over IP, total routing freedom.
Which leads right into video walls. Handling those must be easier with this architecture.
Absolutely. The source says it supports any size video walls and any quantity video walls. Because it's all software-defined routing over the network, grouping displays together and synchronizing them for a video wall is much more flexible than trying to wire that up physically on an old matrix.
Makes sense. Okay, performance. For something like a sports bar or maybe a trading floor, speed matters.
Yeah.
How fast is the switching? And what about latency? The delay.
The spec sheet claims 80 milliseconds for both switching time and latency.
80 milliseconds is that?
For an IP-based system doing compression and decompression, yes, that's actually very fast. Think about it. If you have screens side by side showing the same game and the delay is too long, you'll see the action happen on one screen before the other. It looks awful.
Right, that would be really jarring.
So keeping that latency down to 80 meters means everything looks synchronized, near real time. It's crucial for that smooth viewing experience with live 4K 30 streams.
Good point. So fast response. What about control signals beyond just the video? They mentioned KVM support.
Right. KVM keyboard, video, mouse, plus unlimited computers and 3 USB ports on the units.
Why is KVM important at this scale?
Well, imagine a control room or a security monitoring setup. You might have multiple computers you need to control, but only one workstation with a keyboard and mouse. KVM support means this system can route not just the video from a computer to your monitor, but also route your keyboard and mouse commands back to that computer, all over the same CT6 cable.
So you can switch which computer you're controlling from your desk just by switching the KVM feed through this system.
Exactly. It integrates workstation control into the AV distribution. Super useful in command centers, operations hubs, places like that.
Okay, so we've got the hardware flexibility, the scalability, the speed. But managing, say, 70 screens and 14 sources sounds like a nightmare if the control interface isn't good.
That's always the challenge with large systems, yeah. How do you actually use it easily?
So how is it controlled?
The standard ways, Wi-Fi apps for iOS or Android or software on a PC. Pretty typical.
But there was one feature mentioned that sounded like a real game changer for the operator.
You mean the iPad real-time video preview?
Yes. Tell me about that.
This sounds incredibly useful. The idea is on the iPad Control app, you don't just see a list of source names like Satellite 1, Blu-ray 2. You actually see a small live video preview thumbnail of what each source is showing right now.
Oh, wow. Okay, I can immediately see how helpful that is. You're in a busy environment, maybe that sports bar on game night, and you need to put the main game on TV 12. Instead of guessing if input 7 is the right feed, you just look at the thumbnails on your iPad, see the game, and route that source.
Exactly. It takes the guesswork out completely. You see what you're switching before you switch it. Should dramatically reduce errors.
That seems almost essential when you have a dozen or more potential sources.
I agree. It moves from abstract labels to visual confirmation.
And they take this control idea even further with an optional package, right? Something called the sports bar system.
Yeah, this shows how the platform can be more than just video routing. It becomes a full venue control solution.
So what does that add?
This optional system, controlled via the same iPad interface, lets the operator actually change the channels on the source devices themselves.
You mean like tell a DirecTV box to switch to ESPN?
Exactly. It mentions support for changing channels on DirecTV, DISH, cable boxes, even Roku devices.
Whoa. So the system sends out IR commands, or maybe serial commands, to the actual source boxes.
That's how it works, yeah. The control signals are integrated into the AV over IP network along with the video. It really delivers on that any channel to any TV promise because the control is unified.
That's a big deal. No more juggling AV routing controls and then a separate remote for the satellite box.
Right, and it doesn't stop there. That optional package also includes integrated audio control.
Okay.
And, maybe most impressively for managing a complex space, the interface can apparently show the venue's actual floor plan.
A floor plan? On the iPad?
Yeah, showing where all the TVs are located with maybe their current channel listings overlaid.
So instead of routing to TV 37, you tap on the icon for TV by the main entrance on the floor plan.
That seems to be the idea. It makes managing the whole space incredibly intuitive, especially for staff who might not be AV experts.
That really elevates it from just hardware to a tailored application solution. One person with an iPad runs the whole show.
Visuals, audio, channel changes, all from one interface, knowing exactly which physical TV they're controlling. Pretty powerful for that specific market.
Okay, last piece, but a really important one for anyone actually buying this stuff. The cost model.
Always crucial, especially for large deployments. The source lists that core unit, the transceiver that can be TX or RX, at $250.
Which seems pretty competitive for a 4K AV over IP endpoint.
It does. But the really big headline, financially speaking, is probably the licensing.
Let me guess. No recurring fees.
Bingo. The literature explicitly states no monthly license fees.
Okay, that is huge, because a lot of these sophisticated software-controlled AV systems come with ongoing license costs, right, per endpoint or per year.
Very common, yes. Those recurring OpEx, operational expenditure costs, can add up significantly, especially when you're talking about 50, 60, 70 endpoints.
So eliminating those fees makes the total cost of ownership, say over 3 or 5 years, much more predictable and likely lower. It becomes a capital expense upfront, not an ongoing drain.
Exactly. For enterprise buyers or large venues working with fixed budgets, that zero license fee model is incredibly attractive. Turns it into a long-term asset purchase.
And they also mentioned you can build your own system. So you buy exactly the number of transceivers you need.
Seems that way. Highly flexible procurement. You get the dual-role hardware flexibility, the competitive unit price, and no ongoing software fees. It's a strong financial argument.
Okay, so let's try to wrap this up. Synthesizing everything, the real value here seems to be, what, 3 main things?
I'd say so. First, that architectural flexibility, the dual-role hardware running over standard 1 gig networks thanks to H.265.
Right. Second, the sheer scalability, going up to dozens of screens, video walls, all managed centrally.
And third, that really advanced integrated control, especially that iPad preview and the optional venue control system. It makes managing the complexity feasible.
It really does blur the lines, doesn't it? It's not just a matrix switcher anymore. It's like AV distribution as a network service you can manage in a very granular application-specific way.
Yeah, the network is the matrix, essentially. The old limits of a fixed chassis are gone.
Which leaves a really interesting thought for you, the listener, to chew on. This kind of deep software integration like that sports bar system. Does that create a new kind of vendor lock-in, even though it uses standard IP networking? Or does the use of AT6 and IP keep your options open down the road?
That's a great question. The trade-off between deep integration and future flexibility.
And maybe a second thought, that no monthly license fees model is compelling. But where is the tipping point? How many screens do you need before that zero OpEx model definitively beats a potentially more feature-rich subscription platform over, say, a 5-year lifespan? Doing that math is probably the real deep dive for anyone planning a big deployment.
Absolutely. It's where IT network knowledge meets AV needs meets financial planning, a complex intersection.
But definitely a fascinating look at how AV is evolving for these large-scale applications. Thanks for digging in with us today.